Much of the world's conflict happens in areas rich in biodiversity, and war makes conservation a complicated issue. In 2016, a group of researchers published a paper exploring important questions about conflict and conservation. Can conflict be included in planning for protected areas? What strategies actually work when wildlife and warfare mix? The researchers from 2016 concluded that we need better, more fine-grained data on the impacts of conflict, and a new paper in this week's Nature drills into historical data to provide just that. Authors Joshua H. Daskin and Robert M. Pringle report that even low-grade, infrequent conflict is sufficient to cause harm to wildlife. But they also conclude that the mere presence of conflict doesn't mean that the wildlife in that region should be written off. Decades of conflict between 1950 and 2000, write Daskin and Pringle, the majority of the world's conflicts occurred in Africa and Asia. And more than 80% of wars overlapped with biodiversity hotspots. These hotspots are home to some of the world's last diverse large mammal populations, they write, which makes conflict in these regions all the more alarming for conservation. Daskin and Pringle focused on Africa to figure out how conflicts had affected large mammal diversity. They looked at historical data on all the conflict zones across the continent between 1946 and 2010, highlighting the dates and geographical areas affected in every recorded conflict that had caused at least 25 human deaths. They then looked at places where conflict overlapped with protected conservation areas. They rated each region by conflict frequency, as well as conflict intensity, so that a region that had seen one very intense period of bloodshed could be distinguished from a region that had seen multiple periods of low-level combat. To see how these conflicts had affected the local wildlife, they scoured the scientific record to find data on wildlife population that had been recorded throughout the same time period. Again, to make the task more manageable, they narrowed down their focus, looking only at large herbivorous mammals. Anything over 5 kilograms counted. After extracting the most reliable data, they were able to track the size of 253 different populations, across 36 different species, from 126 protected areas in 19 countries. The researchers looked at when each population had remained stable, declined, or grown in size, as well as that was related to conflict in the region. They found that conflict frequency was related to a decline in population size, but that conflict intensity didn't have the same relationship. That implies that it's frequent disruption, rather than the scale of the conflict, that causes damage to populations. Not a simple story. How exactly do conflicts affect wildlife? That's a murky question without an easy answer. War-weary humans might have a tendency to hide out in wild areas, hunt animals for meat, and funnel money away from conservation and toward military efforts, all of which have an impact on biodiversity. And some empirical studies looking at specific conflicts have found that each of these factors plays a role. But other studies have actually found that conflict can, perversely, have some positive effects. Conflict might also lead to a reduction in poaching or hunting, or generally cause people to avoid certain areas, allowing animals there to flourish. Daskin and Pringle call for caution in how we think about the impacts of conflict. If we just assume that a region that's been torn apart by human conflict is a write-off, we might fail to invest in conservation there when, in fact, it may still be entirely salvageable. Reassuringly, they found that there were very few events that caused whole population extinctions, even at sites with high conflict frequencies. Funding for conservation is limited, so deciding how to allocate scarce resources is hugely important, and it's not possible to allocate resources without understanding all the factors at play. A lot more data is needed on the effects of conflict, but Daskin and Pringle suggest that, for even with what we have now, conservation organizations can start to think about its effects when they plan. Nature, 2018. DOI 10.1038 Nature 25194 About DOIs